Welcome to Three Thoughts On. This is Rafael Andrade. Today my guest is Clint Graumann. Clint is the CEO and co-founder of NUVIEW. NUVIEW is revolutionizing the Earth observation industry by building the first commercial satellites designed to annually map the planet's entire land surface with LiDAR technology. This earned them a spot as one of Time Magazine's 2023 Inventions of the Year. For those of you not familiar with LiDAR, it stands for Light Detection and Ranging, and it's a technology that uses lasers to measure precise distances and movement in an environment in real time. The basic principles of LiDAR are similar to radar and sonar in the sense that all three technologies emit energy waves to detect and track objects. While radar uses radio or microwaves and sonar uses sound waves, LiDAR uses reflected light, which can measure distance faster, with greater precision, and higher resolution than either radar or sonar. You may ask, why does this matter to me? Well, satellite imagery helps scientists keep track of how our planet's natural and man-made environments are changing. The detailed topographic maps this technology can generate can be used to assess hazards and natural disasters such as lava flows, landslides, tsunamis, and floods, as well as other environmental and conservation situations. Outside of that, use cases can include archaeology and cultural heritage and preservation, as well as infrastructure construction and urban planning. We live in times where technology is blamed for eliminating jobs. It is companies like NUVIEW that use technology to create a new generation of jobs that can help us take care of our environment, all while improving our quality of life. As a Lake Nona resident and entrepreneur, I am excited that NUVIEW chose Lake Nona as their home. I'm a proud resident here, and I'm excited about the contributions this community is offering in the fields of technology and health. Clint and I had a great conversation, and I am confident you will find it interesting as well. And now, Clint Graumann. Welcome to Three Thoughts On. Today, I'm very excited to have Clint Graumann from NUVIEW. Clint, how are you doing today?
Great, Rafael. Thanks for having me today.
First of all, I want to thank you. I know firsthand how busy you are. We share space here in Lake Nona. Thank you for making the time. Before we get started, I'd like for you to give us a little bit of background, maybe a couple of minutes on who you are and what is it that you're doing that I am so excited for you to share with this audience.
Sure. Yeah. So like you mentioned, I'm Clint Graumann, CEO and co-founder of a company called NUVIEW. We're building a constellation of satellites that image with LiDAR, which is basically safe, invisible lasers from a sensor in space that measure the Earth extremely precisely. My background, I come from about 15 years in Earth observation, working with satellites, everything from optical imagery, like what you see on Google Earth, to radar imagery in the form of synthetic aperture radar, which can see through clouds and see at night, as well as hyperspectral imagery, thermal imagery, and it's a wide world out there and lots of different ways to understand what we do on the planet. But that's my background and my passion and what I do on a day-to-day basis.
That is fantastic. I am actually personally excited. My background is in engineering and telecommunications, so I am familiar with earlier versions of LiDAR, and I'm excited about what you guys are trying to do and that you will do. Can you get started with the audience? The goal of this podcast is to take potentially complicated things like this that the average person may not think is relevant to their day-to-day lives, but that they're actually very relevant to their day-to-day lives. So can you give us a summary of the overall use of the technology and how it could impact the lives of people on a day-to-day basis?
Sure. We could be here for hours if we talked about all of the ways that this data from these satellites can be used. But I usually try to bring it back to something, as you said, that affects people on a day-to-day basis for things that they do in everyday life and may not realize that satellite data or data from space affects what they do. And so one of the ways that our information that comes from our satellites will be to understand very precisely in the scale of centimeters how things are positioned on the Earth. One of the really unique things about LiDAR is that when it collects imagery, it collects natively in 3D. Most of the purists out there would actually jump on the fact that I just called it imagery because it's really a measurement with a laser, right? And if you think about, if you've ever done a do-it-yourself project at home and you've tried to measure something with a tape measure, there's this old saying, measure twice, cut once, right? And with a laser, you can get so much more precise than what you can with a ruler or a tape measure. And so that type of technology that you do with a laser measurer at home, when you do a do-it-yourself project, that real precision, we're bringing to space technology to be able to image the planet and understand exactly, for example, how high mountains are or what slope in agriculture that a field is. How much of that field is facing the sun so that crops can grow and so that you can understand if you water that crop, where's the water going to go? If you put fertilizer on it, where's that going to go? And then in addition, there are other applications that really affect the community, the global community, like understanding how much carbon is sequestered in a forested area. Right now, when we try to understand that, much of that is done with satellite imagery that just gives us really some reflectance of what the top of the trees look like. And with LiDAR, you can see the top of the trees, you can see through the canopy down to the ground and measure the difference in between those 2 points, the top and the bottom. You know how wide the tree is, and suddenly you can understand how much carbon or biomass is stored in that tree. And then you take that and apply it across an entire forest. And we can really start to understand what we're doing when deforestation happens, what we're doing when we log and use that biomass for some other purpose. And if we're trying to understand how much is really there, we go from guessing to actually accounting for what we're doing.
Well, that is very interesting. So let me present something to you, and I'd like you to comment, critique, correct me for the sake of the audience here. So LiDAR in itself has been around for quite some time. And it is something that has developed over the years from different types of models. We've scanned the surface of the oceans using a different type of LiDAR with green light. We have LiDAR using automotives, for different types of, urban type of applications. And up to now, when it comes to looking at things from above, we've used drones and we've used airplanes to be able to see the Earth a little bit from above. LiDAR, in the application that you guys are deploying, has the potential to not only be cheaper, but also far more accurate, being able to do far more land mass at any given point in time, which all those together, at least to me, it seems like it could make the technology far more available to far more people and applications than it currently is today. Am I saying this right? Am I looking at this the right way? Or can you please comment on that?
Absolutely. That's the whole premise behind why we decided to build NUVIEW, is that right now you can only image LiDAR from an airplane or a UAV, which gives you real problems when it comes to scale. The data is amazing. The LiDAR data is amazing, except you can't do very much with it. And so we're building a system that can take us from a point where we've only collected data on about 5% of the planet to being able to do the entire planet every single year. And with that, you can start to understand more accurately and more precisely about how things are changing. And by the way, that was a great comment on using LiDAR for bathymetry in water with a green laser. You're in the top 1% of people who have ever interviewed me to know that factoid.
Well, I have a history in telecommunications, cellular telephony, 27 years I was in that. So LiDAR has always been something that was interesting to me living here in the Space Coast, for 32 years. So I am a little bit of a nerd on that. So let me go back to something you said, because when you're talking about resolution of the data, right? Resolution is super important. I'm aging myself, but I remember the old days of 1G, which, were the original cellular networks, and 2G. We would use tools like MapInfo, right? Mm-hmm. to load up the topology and morphology data. And I remember the day when we were able to purchase 3-meter data. And that was the most exciting day as an engineer, when you can actually load up into a propagation tool 3-meter data and see what the model will show as far as the propagation coverage of the potential 2G, 3G data. You're talking a lot smaller than that. Can you comment on that, please?
Sure. One of the traps that the world falls into when they talk about LiDAR data versus optical or radar data, often, people want to talk about the spatial resolution of it, and it's a very different subject when you're talking about LiDAR. The type of things that we try to point people to is understanding the accuracy of the data, usually in terms of vertical resolution. So how close is that object that you're trying to image to where it's actually supposed to be in Z, or the vertical, up and down. If you're not an engineer on this call, it's how close is it supposed to be to where it is in up and down format. And so when you're talking about resolution at 3 meters, that's the spatial. So that's like having a 3-meter grid on the ground. And that's the size of a pixel on your computer when you look at it. And so we'll be better than a meter. And that's just really how we sample things and how we grid it out. But really the important thing about LiDAR is how many points, or how many laser points we can send out and collect back within a meter. Can we do 2? Can we do 10? Can we do 30? And every single point that you put out there gives you a lot more clarity on what you're looking at, because it's all collected in 3 dimensions when you use LiDAR. Now, when you get to accuracy, what we're really looking to do is be accurate within about 10 centimeters as our target. And so 10 centimeters, in inches, it's a little better than a couple of inches. And we want to be able to present to the world a globe that's in 3 dimensions based on LiDAR data, that we know the elevation of everything to an unbelievably precise level. And then we're going to cut it up into grids that are smaller than a meter. There are ways we can get even better than that, but we want to create the best elevation model that's ever been created, on which all other geospatial data sits on top of.
And do that in a commercial way, right?
Exactly.
So it becomes available for the globe, really, to then use for the myriad of applications that we know of and the ones that we don't even know of moving forward. That's, to me, to be honest with you, is one of the most exciting parts about it, is when we take technology that, not necessarily in this case, but that in other cases where, governments or, the federal government develops but it's not available, for the commercial world. I see this as something that could really change some of the areas that are true in my heart, like environmental monitoring and conservation, right? My middle son, he's an environmental scientist, so he reminds me every day of the importance of taking care of our planet and stuff. And I believe this is one of those technologies in that package that could allow for us to do a bit better in that field. How do you see that? How does LiDAR help environmental monitoring and conservation?
Yeah, without getting specific on the different types of LiDAR sensors that would need to meet each need, when you talk about LiDAR being able to solve problems, one of the things that we know today based on data is that global ice and snow water equivalents are melting. And that's going to have a huge impact on the planet. We also know that coastline is eroding, and all of the effects on the planet are making these things change. And the results of that could be catastrophic if we don't get ahead of it. And so what we want to do from an environmental perspective is, one, we've got to start where the problem could be starting. And that's, how do we preserve carbon? How do we sequester carbon and keep photosynthesis churning? How do we know what's actually there? Because if you can't measure it, you can't manage it, right? And so we want to give the best data that's ever been available to be able to help manage that problem. And as we start to understand coastline, the vast majority of the world's populations are close to coastline. And we want to be able to, instead of monitoring that coastline for change every few years, we want to be able to revisit that on an as required and on-demand basis to understand how coastline is eroding and changing and how people's lives are affected there. And one of the real-world problems that if you think about how that can change us, if you think about Hurricane Katrina, back in 2005, we had models for floodplains, but if we think about how we prepare for that, if we understood precisely in the scale of centimeters where water would most likely move should a surge come into land, that could be the difference of understanding whether the water is going to go over your ankles or whether it's going to go by the roof of your house. And the damage from that and the lives that are changed, there's a huge difference there. And so we want to be able to provide foundational geospatial data by which all environmentalists and the science community have irrefutable facts on what the baseline is and how things are changing.
So if I go back to that example, that requires an ecosystem through which, of course, you have the constellation of satellites doing what they do. The signal is coming up and down. The measurements are being collected. But now you have to deploy this into some sort of cloud-based calculation engine, if you will, that's actually going to do something with this data. It seems that part of it is quite an important part of the entire system because that's what's going to give you the confidence that the data collected is actually useful for the various applications, right? Is that something you guys are also working on? I mean, is it a full package with NUVIEW?
Yeah, one of the biggest challenges that I've seen in the business of Earth observation are the startups that build a great center and they've got no way to get that data to the community. And so that's actually one of the three core pillars of how we're building our business. And we call that part of the ground segment. So how do we take everything that we're collecting and processing in space, delivering that to the ground? How do we get it to the people in the community that need it? And so part of our foundational work is creating really a SaaS platform that the user can access data in the cloud. And we're going to do something that most people have never envisioned, and that's take that data and make it streaming so that it's accessible. And where I came up with the idea, I actually, it's not incredibly novel today, but quite a few years ago, I worked in optical Earth observation, and everything was really project-based. We need imagery over this area. And back in those days, we were sending it out on a hard drive or putting it on an FTP. And one night I was watching Netflix and thought, how can we possibly get this to people that need it more efficiently? And so the idea, everyone today delivers satellite data via API in a streaming way, but LiDAR data is still not in that format where it's just on all the time. So we want to be able to deliver that data into a cloud-based environment where the most constant and refreshed and updated LiDAR data is available, and it's available in layers that's been taken at different times. And imagine, like you see in Google Earth, we have a slider effect going back and forth to be able to see how things have changed optically. This data is machine readable, but it's also viewable in a way that you can see how the three-dimensional change is happening back and forth. And so to answer your question a little more precisely, yes, we're doing that. It's foundational to what we do, and we're closer than you think.
Oh, that's exciting again, because I think that is part of the challenge, at least that I've seen in my lifetime with technology. I'm a big fan of technology, is that the average person doesn't appreciate it to the level that at least I think they should. Okay. I've made a career in cellular telephony, and people take it for granted because they expect to take a piece of plastic, glass, and metal and push a screen and talk to their relative on the other side of the globe without even knowing what it entails for that to take place. So they pretty quickly they take it for granted and say, this doesn't work. And I think one of the important things for all of us to do in this field of technology, especially with innovative technology like what you guys are doing, is to evangelize it to the people, right? So that they push their municipalities, right? The counties, the cities, the states, and the governments, they demand that they use it for day-to-day things like traffic management, conservation, infrastructure, construction, planning. The list goes on. We need as technologists, we need to do a better job at promoting how can this change your life if it was available.
Right.
Right. And based on what you said, it seems like that's exactly where you guys are going.
Yeah. And, we're still in that world where people don't understand how space-based technology helps them every single day. And I don't believe we'll be there until I stop hearing the question or hearing the statement, actually, why do I need GPS? I've got Google Maps, right? And when I stop hearing that question, I'll know we've gotten there.
We have a colleague here that we share space with also from Tavistock, Juan Santos. He and I had an episode where we specifically talked about that.
Oh, wow.
This podcast on how space exploration has made things that are day to day today, So let me go back to the use cases, because again, I really want our listeners to get a feel on two areas. One is what are some of the really interesting use cases for this type of technology, but also to inspire a little bit on where are the opportunities.
Sure.
We just heard from Forbes, about 350,000 tech jobs were lost here in the United States last year. So there's people out there looking for opportunities, right? So on one hand, there are use cases. I mentioned one of them. We've talked about, environmental monitoring and conservation, but there's others. What do you see as some of the really good use cases that this technology can facilitate for the communities today?
Yeah, I think one of those really great use cases is in the energy sector and renewables, right? One of the things that we know in renewable is that wind energy can be an incredibly powerful source of energy along with solar. With normal satellite imagery, like you're probably familiar with, it's pretty hard to understand the angle, the sun angle that's there, or what the lay of the land looks like to get the best, direction of wind coming through for wind energy. But with LiDAR imagery or LiDAR collections and measurements, what you can see is a really good understanding of the topography, the elevation, the angle, so that solar can be positioned in the best way possible so that you can have a great pathway for wind energy. And in addition, one thing that we don't think about very much is the analytics that go behind understanding how energy is transported. And also transporting energy when you're moving it along power lines and corridors, understanding too how to keep people safe in that environment. One of the things that I believe we're going to have a huge impact on, where those involved in analytics could be incredibly valuable. Everyone's probably seen all of the fires that have happened in California. Many of those are caused when vegetation encroaches on power lines. And a great thing about LiDAR and what we're building there is an ability to understand that corridor, whether there's vegetation that's starting to grow and encroach, and sending people out to do that verification is awfully time consuming. It's challenging. Flying an airplane can get super expensive. And what we're hoping to do is provide big data sets where the growth in AI and ML capabilities will be able to start to find that information and digest it in an automated way. And we need analysts to build those things. We need to understand, if coastline is changing, we need analysts to be able to build the tools to be able to understand where coastline is changing and where it could be a problem. We need to understand where there's subsidence in areas that are mountainous, and we could have effects from that could harm people and communities. And so it would be tough for me to say, all of the diverse ways that people can get involved, but on a high-tech basis, LiDAR data, in my opinion, is the absolute best data from space or geospatial data, absolute best data for AI and machine learning capabilities, because each laser point has really a lot of discrete values that make it great for analyzing by machines. If you look at Google Earth, it's very cosmetically pleasing. It's great for the naked eye. If you look at radar imagery, it's super grainy and there's a ton of amazing information in it, but it's hard for people to really see and understand what's happening there with some expert training. But the great thing about LiDAR data is it's built for machines. Like you get into AI and machine learning capability, it's machine readable, and there's probably no data set that could be analyzed better by AI and ML capabilities than LiDAR. And so I'd love to see a lot of those in the tech community bring new ideas to the forefront on how to work with that data and then be able to scale data, because right now we don't have LiDAR data at scale. So there are two things out there. What are we going to do when we have more data than we've ever had access to in our life? And then what new problems are we going to solve?
Is there an opportunity, down the line to create a hybrid LiDAR model, meaning we have LiDAR applications today that are stationary LiDAR, where sensors monitoring a specific type of data in a specific city. We also have the most common one in the automotive industry, where you have the cars, looking at each other and sensing each other through those mechanisms. Are these technologies compatible for collaboration with the technology you guys are deploying?
Absolutely. I won't say that we've gone down that path yet, but I absolutely see that one day there won't be this big divide between pools of data, the only difference in the data is the direction that it's been collected from and the power of the sensor that's been collecting it. Most of the LiDAR that you described at first before going high in altitude is pretty low power LiDAR, and it only looks a short distance out into the future. But with high powered LiDAR from high altitudes combined with those types of data from different directions, you start to get a look at the worlds that we wouldn't have thought possible 10 years ago.
What do you think is, from the work that you've been doing with your team and other interviews, other podcasts, what do you think is the number one misconception that the public has about this technology, if there is one?
Yeah, I'd say that LiDAR technology, probably the misconception would be that we're dealing with lasers that you can see and that are powerful, like what you would see on television. I don't know if you've ever seen the movie Real Genius. It was a movie in the 80s, and they shot this big high-powered laser from an aircraft, and they, I guess, roasted this huge amount of popcorn in a guy's house, and the guy's house exploded with popcorn. Like these big, high-powered, dangerous lasers. And that's not what we're doing with LiDAR. LiDAR's, for the most part, invisible, especially if it's in the near infrared. It's safe, meaning you could, from high altitude, you could look straight at it and nothing would happen. You wouldn't even notice, right? So I think the biggest misconception is, what does a LiDAR look like? Am I going to see the laser? How do I know what's happening with the technology? But I think we're still in the phase where this is a domain that's exploited mostly by autonomous driving. It's exploited mostly from aircraft in high precision mapping scenarios. But it won't be long, once NUVIEW is fully up and running, that I think we'll have a much bigger view on the world stage of what's possible with LiDAR.
So what would you say to the young person coming out of college, or maybe an engineer who's trying to reinvent himself, herself, into this new field? What are some of the things that they could start studying or getting involved in order to be a participant, a contributor into this field?
Yeah, there are two things that I've learned that there's a tremendous amount of value in different positions in this field. One of them is data science. Like, this is going to be an immense set of data, and finding new ways to exploit that data for good, I think is really great. And I've also seen through our own team at NUVIEW and through the interviewing process as we're starting to build up that team, like there are so many people in different engineering fields, electrical engineers, mechanical engineers, aerospace engineers, that have a talent and a crossover capability into data science. And so that's one of my favorite skill sets that I would love to see more people deep in data science. The other one I would say is I've gained an unbelievable appreciation for product managers. And that's a very diverse skill set. You can have product managers that come from software engineering. You can have product managers that come out of a pure marketing background. You can have product managers that come from any field possible, as long as they have one attribute. They care immensely about how the product that they create is used, and they care immensely that it's solving the problem of a real user. And I think that would be the way that I would say to young professionals or new into the field that want to come out and give it a go is care about those two things. And a product management role could be absolutely life-changing for you in the cool stuff that you get to do and the amazing problems you get to solve. And then no matter what field you come from, if you can invest in yourself in learning about data science, that's applicable not just in the space industry, not just in the geospatial industry, but in any industry really. And I think that that's a great way to level up your capabilities.
Well, that's fantastic. And just to expand a little bit on that for the audience, in the world of NUVIEW, a product is basically a deliverable to a user that can use your data for a very specific application, correct?
Yep. A product manager should always be asking, what problem am I trying to solve? And then follow that with who am I trying to solve it for? And so as you move in that direction, a product manager takes the requirements of the user. So someone on the ground that's trying to solve a problem, let's say that they work in energy and they're trying to solve the problem of fires starting near power lines. Like you would want to work with that community to understand what are the things that are causing these fires? And is there a preventable way that we can go about it? And then take that information and translate it to the people that are building the satellites and the LiDAR. And you tell them, here's the end result that we're trying to achieve. Let's build requirements for how this satellite and this sensor are constructed so that this problem doesn't happen anymore. But that's applicable in any industry. Like we love to see that in our business, but you can take that and that's a transportable skill set anywhere.
That's fantastic. Well, Clint, I would like for you to leave the audience with 3 thoughts. You can pick any 3 thoughts, whether either 3 things that you're most excited about the future of this technology, the way that you guys are going to be delivering it, or the call to action for people out there. You've already touched on some of that a little bit on. What are the 3 things in any kind of mix that you want to leave the audience with regards of LiDAR, NUVIEW, and how it can truly impact people's day-to-day lives?
Yeah, I would say that the number one thing is that accuracy matters. And that's the biggest reason why we're trying to build a sensor that doesn't exist commercially anyway in space today, is that we want people to understand with the best accuracy possible how they can solve their problems and to have the right data to solve the problems. We also want to have a positive impact on our local community. We want to have a positive impact on the global community. And I've worked in so many different places around the world in different fields, and we want to provide data that is meant for good and solve so many different challenging scenarios. And 3, never stop pushing the boundaries of what everyone thinks is possible today. That scenario where people say that something can't be done, it's very different than saying it shouldn't be done, right? And so we're in a place where we're the very first company in the world to build commercial LiDAR satellites to map the planet. And we believe that we don't even know all the problems that will be solved with what we're doing, but we're the first because so many people said that it couldn't be done. And here we are developing the LiDAR. We're hitting spec. We're getting things done. And I would compare it to, the sub 4-minute mile, that forever people said a human couldn't run a mile in less than 4 minutes. But once it happened, it became table stakes and everyone had to run sub 4-minute miles. And that's where we are. NUVIEW is the first to, philosophically break the 4-minute mile. And we hope that we're the rising tide that lifts all boats and the world becomes better because everyone becomes better.
Great reference there to Mr. Bannister from England, who did that feat a long time ago. Well, I tell you, before we close, I am excited about one particular use case. I'm a technologist during the day, but I am a history buff at night, and the archaeological and cultural heritage and preservation field, the idea that through this technology, things could be found and unearthed, that to me is just super, super, super exciting. So I can't wait. Where could people find more about you and your company, Clint?
Yeah, you can just go on the web to NUVIEW.space, NUVIEW.space. And these days a Google search will land you quite a bit of information about the company as well. And soon, as you referenced earlier, we'll have our software platform out and live for people to give a test run. So I'm excited about all three of those things. Feel free to reach out. We're easy to find on the web. And we'd love to learn about what you're trying to do with LiDAR.
That is fantastic. Clint, again, thank you for your time. I'm greatly appreciative of it. I hope you have a wonderful weekend, and I'm sure I'll see you next week here in the office.
See you later. See you next week. Thanks again.